mathematics, we often need to prove precisely formulated mathematical statements. Mathematical proofs are logical arguments that show the validity of statements, and they must be rigorous and unambiguous. In fact, mathematics is distinguished by such proofs, as they are typically not available in other fields. For example, in the court of law, one is only expected to prove things beyond reasonable doubt. In the sciences, theories can only be supported by evidence and cannot, in general, be proved absolutely. For example, in medicine, clinical trials can only show that new drugs are likely to be effective with high probability. However, there is always a small chance that the outcomes of the trial were misleading and that the drug does not work as it should. Mathematical proofs, in contrast, are absolute and not subject to statistical uncertainty. Since mathematical proofs are rigorous and unambiguous, it is also important that the statement to be proved is precise and that all terms used are formally defined. So what is not a proof? Showing that the statement holds for one particular example is not a proof, as a proof needs to hold for all instances of a problem. For example, the statement, "the product of any two consecutive integers is even," is not proved by, "Consider integers 5 and 6. 5 times 6 equals 30, and 30 is even." So how could we go about proving this statement? We could try to use a proof by exhaustion, where we would need to check every pair of consecutive integers. Unfortunately, the number of such pairs is infinite, and we would never finish checking. Therefore, we have to think of another strategy. In general, constructing a proof requires a lot of perseverance and creativity. A dead end is not a signal to give up, but rather a sign that we need to attack the problem differently.